Today we'll see a program on decimal up counter. The decimal up counter counts from 00 to 99. To generate the delay between the counts, the software delay routine is used. Okay, so here we are not using timer to generate the delay. The delay is generated by the software delay routine. So in software delay routine, so we are executing certain set of instructions repeatedly so as to generate the required delay. Let's see the program first. So initially we are having org0h, which is nothing but the initialization of the program. The PC is loaded with the 0h and our program is going to be placed at our program opcode is going to be placed at the address 0h, starting from address 0. So here the next instruction move a comma hash 00, the accumulator is loaded with the 00. So now once I load the accumulator with the 00, I am calling the delay routine using the instruction a call delay. A call is absolute call. So once this instruction is executed, in that case the address of the next instruction, which is nothing but the content of the PC, is stored onto the stack, and the PC, that is program counter, is loaded with the address of the delay routine. Okay, so the delay routine is here. So here is I am having the delay routine. The address of the delay routine is loaded with the PC and the control is transferred to the delay routine. In the delay routine, so what we are doing is we are loading the value ff in R1, R2, R3 register, and we are continuously decrementing the values and looping the same instructions. Okay, so this is nothing but software delay. So here the set of instruction, I'll make them to execute repeatedly so as to generate the required delay. At the end of the delay routine, I am having the return instruction. The return instruction gets the control back to the next instruction following the call instruction. The next instruction following the call instruction is add a comma 01. The content of a was 00. It stayed 00 for some time. By using the delay routine, we have generated the delay. After that, I am incrementing the content of a by adding with the 01. So now 0 plus 1 is 01, which will be there in the A register. Okay. So next instruction, here the counter we are implementing on the A register. So the next instruction is DAA. DAA is decimal adjust accumulator. So this instruction adjusts the content of A. So it is used for BCD correction. Okay. So in BCD, so we are having only from 0 to 9. After 9, the count will be 10. To get the result in the BCD, so we are using the DAA instruction, decimal adjust accumulator instruction. Okay. So after this, so A01, so it will be 0 in after this DAA also. Now the jump on not 0 instruction checks the content of the A register. The content of the A register, if it is not equal to 0, it goes to the back label. Okay. So the content of the A register is 01 now. It is not equal to 0. So it goes to the back label. Again, we are going to call the delay routine so that the count 1 will be retained for some time. Now add A with the 1 is nothing but it is 2. So the 2 will be displayed. DAA instruction used to adjust the content of the accumulator. Like this, the loop is repeated. Okay. So for example, if I am having add A, so in the case of A is 9, add 9 with a 1, so results in the hexadecimal value of 0A. So now the DAA instruction, so it adjusts that hexadecimal value to the decimal is nothing but, so instead of 9, I am going to get, after DAA, I am going to get the value as 10. Okay. So the same loop is repeated again and again, so until the count becomes 99. So once the count becomes 99, okay, so add a comma 1 is nothing but, so it is 9a. So DAA instruction, adjust it to the decimal. So by adding 6 to the LSB, the lower nibble and the higher nibble based on the carry and the auxiliary carry bits. Okay. So 9A, when I use the DAA instruction, it becomes as 100. Carry flag is 1, content of A register is 00. Now jump on not 0 instruction checks the content of A register. The content of A register is the content of A register is 00. So it comes out of the loop. So like this, the content of the A register is incremented from 00 to 99 and back to 0. Once it becomes 0, it comes out of the loop. And next we are having the instruction SJMP here, where the label is given to the same instruction. So is nothing but, so SJMP is unconditional jump. So the control stays in this loop until I terminate the program. So in some cases where I'm not having the in some editors where I'm not having the option to terminate the program or monitor programs, in that case this instruction is used to terminate the program. Okay, so this is the case. So this program counts from 00 to 90 time. So we'll see the execution. The program is written in the file up.asm. Already we have created the project. So if you want to create the new project, you can do the new project, or you can use the one already created. Okay, so previously one file was there. I'll just remove that file so that I can add this file to the project. Okay, I click on the source group. I'll say add files to the source group. The file name is up.asm. I'll add that up.asm, add, then close. So once I do that, I'll go to the project. I'll build the target. Okay, so by building the target, if any errors are there, it will be displayed. No errors. I'll go for debugging the session. I'll click on start the debug session. Okay, so now here we are observing the register A contents. So the register A content should act as a counter. So it's nothing but I'm observing the content of register A on the watch window. Okay, so I should open the watch window. So go to this view. So in the view you select, so watch and call stack window. Okay, so the watch and call stack window will be open. Otherwise the option will be here, watch and call stack window. You can click on that to make this watch and call stack window open. You can select either watch 1 or watch 2. I'll just select the watch 1. Okay, so here it is given type F2 to edit. So I'll just type F2 or press F2. So click on this and then press F2. Okay, so now I want to observe the content of A register. I click on the A register. Okay, so now I'll run the program. You can observe this here in the A register. The content of A register keeps on incrementing until it reaches the 99. After 9 it becomes 00 and the counter stops. Okay, you can observe the output here. So now I'll go for debug and I'll do the run. Observe the output here. So it is 1 2 3 4 5 6 7 8 9. After 9 it is not A, it is 1 0 1 1 1 1 2 like 12 13 14 15, because we have used the decimal adjust accumulator instruction. It is a decimal up counter. So only decimal values are counted from 00 to 99. Like this the counter goes till it reaches the value of 99. So here you can also decrease the delay. You can to decrease the delay. So in for R1 register you decrease the value, the FF I've given, you decrease the value of that, the count of that, then the delay will be decreased. Okay, so it's going 55 56 like this, 60, 68, 69, and the counter keeps incrementing. Okay, so it's going around 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 0. So once the content of A register becomes 0, jump on not 0 instruction phase, it comes out of the loop. So where SJMP here, it stays in the infinite loop. So to terminate the program, I should halt the program. So by pressing this halt, so now the program is terminated. So now I can say debug, stop the debug session to go back to the editor. Thank you. This is the execution of the decimal up counter.